Okay, so I'm going to go through the answers. Hopefully you find these okay. First one, sodium has a positive charge. That tells me it's lost an electron. I'm going to give it 1 electron back and it's going to be neutral sodium again. Magnesium has lost 2 electrons. I'm going to give it 2 electrons back. It's going to be neutral magnesium again. Calcium has lost 2 electrons. I'm going to give it 2 electrons back and it forms normal calcium with no charge. Aluminium has lost 3 electrons. I give it 3 electrons back and it's an aluminium without a charge. Lithium's lost an electron. I give it back and I get lithium. So as we saw before, you always have an ion on the left-hand side. You give it back the number of electrons that it lost and you end up with that same element on the right-hand side, but this time it doesn't have a charge. So ions on the left, atoms on the right. Oh, I literally just did lithium for you, and now we're going to do lithium again. Okay, so here I just asked you to write the full equation, so you actually have to go to the periodic table and find out what the charges would be. Lithium, as we've seen above, has a +1 charge because it's in group 1. I give it the electron back, and it's lithium again. Potassium is in group 1 as well. It's also got a +1 charge. I give it its electron back, and it's potassium again. Copper, you use the Roman numerals. I know it's positive because it's a metal. Metals are always positive. It's got a 2 in Roman numerals. It tells me it's lost 2 electrons. I give it those 2 electrons back and it's normal copper again. This copper has a 1 in Roman numerals. Okay, that tells me it's lost 1 electron. So I only have to give it 1 electron back to be normal copper again. Iron, symbol is Fe. It's got a 2 in Roman numerals. So that's +2. I give it the 2 electrons back and I get normal iron again. Iron, 3 in Roman numerals. This time that tells me it's 3+. It means I need to give it 3 electrons back and it's going to be normal iron again. Okay. Again, on the left, you've always got an ion. You're giving it the number of electrons back that it lost. That gives you a neutral atom on the right-hand side, okay? These signs should match. It's positive, so you're giving it electrons positive, giving it positive, giving it. Those signs are the same the whole way down. Now, what you will notice is in all of these equations, your metals are gaining electrons. Because they are gaining electrons, we say that the metals are reduced, okay? We remember oil rig. Oxidation is loss, reduction is gain of electrons. So in all of these cases, you see that your metals are gaining electrons, therefore your metals are reduced, okay? If we look back at our diagram that we had a minute ago, and from what we did previously, we know that metals always go to the cathode. Because they are positively charged, they will always go to the cathode. When they go to the cathode, they gain electrons. So at the cathode, metals gain electrons. At the cathode, reduction takes place. You can be asked, what is reduction? Reduction is the gain of electrons. Where in electrolysis does reduction take place? Reduction always takes place at the cathode. Okay, the metals have lost an electron, they go to the cathode, they get their electrons back again, they are reduced. When their ions get their electrons back again, they form normal neutral metals again. They're no longer ions, they're neutral metals, which is what we want. Okay, now I'm going to go through the anode and the half equations that you're going to see at the anode. So we saw here, we had chlorine, okay? Chlorine has a negative charge. The negative charge tells me chloride has gained electrons, and if it goes to the anode, it's going to lose them again. So it's going to be the exact opposite to what we saw at the cathode. So I'm going to come over to this page, and I'm going to start by writing chloride. So just like with my last half equation, I'm going to start on the left with an ion, okay, Cl minus, and I need to get it back to just chlorine again as a neutral atom. This minus tells me that chlorine has gained an electron, okay? If I want to get it back neutral again, I need to take that electron away. So I'm going to minus 1 electron, okay? The negative charge tells me it's gained an electron. I take that electron away and it's neutral again. So it's going to be minus 1 electron, gives me a neutral chlorine atom again. What you're going to see, you have an ion on the left, you've got something neutral on the right, and these two signs match, okay? So you've got a minus on your ion, you're going to take away the electrons. Those two signs should always match. Again, it's a half equation. I've only got one element included and I've got electrons. The problem, not the problem, but the kind of slightly harder things about these equations, okay, is chlorine never forms single atoms. Okay, chlorine always exists as Cl2. They don't exist as individual chlorine atoms. So instead of forming Cl, I'm going to form Cl2. Because I've now got 2 chlorines on this side, I need 2 chlorines on this side. I'm going to write a big 2 in front of the Cl minus. Because I've got 2 chloride ions, that means they each have to lose an electron. So in total, I am taking 2 electrons away in order to form Cl2. Now, you may be confused about why I'm using a small number over here when I'm writing Cl2, but I switched to a big number over here when I was writing about the chloride ions. Okay, we need to know the difference between small numbers and big numbers and when we use them. Okay, anytime I've written a small number like this, that tells me that they're actually bonded together. So if I were to draw Cl2, okay, I would have 2 chlorine atoms that are actually bonded together, and we draw these dot and cross diagrams that hopefully we can all draw. Okay, 2 chlorine atoms actually bonded together, and the reason they bond together is if I look at one chlorine atom by itself. Chlorine is in group 7. It's got 7 electrons in its outer shell as an atom. It has 7 and it wants to have 8. So rather than each chlorine atom existing by itself individually, what they do is chlorine atoms always pair up. Because when they pair up and they share their electrons and form a covalent bond, which I'm going to draw here, there's that chlorine, 7 electrons, and then this chlorine has 7 electrons. When they pair up and they share their electrons, each chlorine ends up with 2, 4, 6, 8 electrons, 2, 4, 6, 8 electrons. So they never exist as individual chlorine atoms because they can pair up, form a Cl2 molecule, and have a full outer shell. So what's going to happen is those chlorine atoms, as soon as they're formed, they're just going to immediately pair up with another chlorine atom and you're going to get Cl2. Okay, we say all of the halogens are diatomic. They always exist in pairs. So I have to write Cl2. And I'm using a small number 2 just so that they actually are bonded together. Now, if I go back and look at the other side, the Cl minus, why didn't I write the little 2 down here? Well, if we draw Cl minus, okay, remember Cl minus is a chlorine ion. So it has the original 7 electrons that it always would have had. But that minus charge tells me it's gained an electron. So a chloride ion already has a full outer shell of electrons. It doesn't need to pair up, okay? As well as the fact that it's already got a full outer shell. If I had 2 chloride ions next to each other, okay, they both have full outer shells, so they don't need to pair up anyway. But they're both also negatively charged. So they're going to repel each other. There's no way these 2 chloride ions are going to form a bond. So they don't exist as a bond, bonded together, like what we saw over here. They exist completely separately, but there are 2 of them. So what it would look like would be this. I have 2 separate chloride ions. They each lose 1 electron to form 2 chlorine atoms that then form a Cl2 molecule. Those 2 chlorine atoms will bond together and form a Cl2 molecule. Okay? To represent that these 2 are bonded together, I use a small 2. To represent that these 2 are both separate, I use a large 2. You should never, ever, 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 ever write Cl minus with a little 2. That is completely wrong. That tells me those 2 chloride ions have formed a bond, and they wouldn't because they've got their full outer shells already. They're negatively charged. They'd repel each other. Okay, so this is your half equation for the anode. Okay, you can see that you are losing electrons. So this is oxidation taking place at the anode. Again, this video is getting slightly long, so I'm going to pause it. I'll stop it. We're going to go to the next video. And what I'm going to do in the next video is I am going to go back to my worksheet and I am going to start working on the half equations at the anode, which we've said is oxidation. I've already done chlorine for you, so try and do chlorine yourself. Bromine, fluorine, iodine, they're all in group 7, so they're all exactly the same. So rather than just waiting for me to do them, have a go at them yourself, see how you get on, and then watch the next video and you can correct them. Oxygen's a little bit different. If you can do oxygen by yourself without looking, well done. Have a go.